Welcome back, guys. We are in free response problem 2B. I apologize for not finishing that one. Here we are. 2B again discusses the last problem where we're talking about delta G and rate. It says a suitable catalyst increases the rate of a reaction. Yeah, we know that. It then goes on to say, what effect does the catalyst have on the delta G for the reaction? Explain. Okay, we're going to draw a diagram first. And we're going to draw the effect of a reaction. I'm going to assume that it's negative and it's delta E. This could also be delta H. Why not? It always helps just to draw this diagram just to get some kiss-up points. Why not? So, again, a catalyst increases rate by decreasing EA, decreasing the energy of activation. What effect does this have on the delta G? Again, no effect on delta G. Okay? Catalyst only increases the rate, does not determine if it happens. Only increases the rate when it happens, but does not determine if. So reaction might be happening slow, spontaneously, and it might be happening fast, spontaneously. Both cases are spontaneous. For instance, the initial EA might have a delta G that's less than 0, and the second EA might have a delta G which is less than 0. Both are spontaneous. This EA happens at a faster rate because the catalyst decreased the energy hill, but both could be happening spontaneously. For instance, this situation here could represent ice melting at 1 degree Celsius, and this situation here could represent ice melting at 20 degrees Celsius. Moving on to the last free response problem, I believe that's free response problem number 3. It says ask the following questions about thermodynamics. Okay, we're going to move through this problem in a stepwise fashion. The following table lists combustion reactions of various substances that sum to the below reaction. So, what we have here are steps. Notice I do not see the word bond anywhere, and I do not see a little f anywhere. So, we're going to use our reaction step process in order to figure out the delta H, even before we begin. And it tells us that this is the overall reaction. Okay, so let's make that clear before we begin. In the empty box in the table above, write a balanced chemical equation for the complete combustion of 1 mole, what the heck, of 1 mole of CH3OH. Coefficients do not need to be whole numbers, so we're going to leave them as fractions. Okay, well, we're talking about combustion reactions. Here it is, CH3OH plus O2 goes to CO2 plus H2O. Going to balance that. 1 here. We do have 4 hydrogens here, allowing us to put a 2 there. 2 O's, 2 O's. We need 4 O's here. We already have 1, so we only need 3, so 3/2. Your instincts are going to tell you to multiply everything by 2, but they want to know the combustion of 1 mole. So we're going to leave it as 1. Cool. Problem A done with. Good job. On the basis of your answer to part A and the reaction step information in the table, determine the enthalpy change for this reaction. Okay, We have three choices again for delta H. Broken minus formed. It is not that because we do not see the word bond. Products minus reactants. It's not that because we do not see formation values, the little f. Reaction steps. It is definitely going to do that. In this case, we have 3 steps. Now notice this question is really cool. They had you create the 3rd step on your own. No big deal. Easy to do. Okay, so let's go through here and let's sum this up. The first one. The first step they give you, what does this reaction and the lower reaction have in common that nobody else shares? H2O is here, H2O is also here, but H2O shows up in the bottom reaction as well, so let's wait to the end for that. H2 shows up in the top reaction and nowhere else, and it actually shows up in the bottom reaction as well. Notice there is 1 mole here and there is 1 mole here, and they are both reactants. So we are going to keep this value at negative 290. We finished that one. We're going to move on. Delta H2. Oxygen is seen everywhere, so we're not going to use that. We're going to use carbon. Carbon is seen as a reactant in the first one, and there is 1 mole of it, seen as a reactant in the overall reaction, and there is also 1 mole of it. They are both reactants as well. Man, this is easy. So we're not going to switch the sign. We're not going to multiply it by anything. We are good there. Last step. This reaction has methanol exclusive to it, which is also present here. We have 1 mole of methanol here and we have 1 mole of methanol here. Notice they walked you into that by telling you to keep it as 1 mole. Methanol is a product here and methanol is a reactant here, so we're going to have to flip the sign. We're going to flip it to 730 and we are going to add all of these values up. So delta H is going to be equal to a minus 780, actually I'm sorry, a minus 680 plus a positive 730. Okay? Minus 680 plus a positive 730, that should give us a positive 50 kilojoules per mole for the delta H value. Around the, yeah, positive. So that's your answer. Good problem to do a couple times. The only thing that was tricky about this is they had you put the value for the combustion of that in on your own. Again, all of the answers tended to be easy after this. On the basis of bond energy, explain why the combustion of H2 is exothermic. Okay, well, bond energy, sum of broken minus sum of formed. Delta H, exothermic means that's negative. If that's negative, the sum of the bonds that are formed must be greater than the sum of the bonds broken. Simple algebra there. So you're getting a lot more energy when you form water than when you break hydrogen and oxygen. Again, according to the combustion of methanol above, how many kilojoules are released if 0.5 moles of carbon dioxide are produced? So we're just going to do a mole ratio here. 0.5 moles of CO2. Moles of CO2 on the bottom, because what you got on the bottom, kilojoules on the top. Going to go up to the balanced reaction, and we know that for every 1 mole of CO2, 730 kilojoules are released. Going to multiply 0.5 by 730. It's going to be 73 times 5. So it's 5, 1, 5. So it's going to be 365 kilojoules. Notice the moles cancel, so there is your answer. Thanks a lot. Take care, guys.